Namaste, sir. Hello, everyone. We are the team 12 have been working on a project drawing boat, which means a boat can draw a simple art forms or a geometrical shapes, etc. We are the four Chetan, Abdul, Priya, and me, Ravi Kumar, under the guidance of Prashant Narayankar, sir. Let's move on to our problem definition. Our problem definition is there is a need for a machine that can draw different art forms of different shapes. The machine should draw a simple art forms on tiles. A machine is made up of standard parts and it must be user friendly and easy to handle. Machine should cost around 2000 to 4000 rupees and our aim is to machine should complete within 2 months and its weight must be 1.5 kg and it covers 2 cubic of feet area and our machine should complete drawing within 2 minutes. And at last, a machine can draw geometrical shapes and a marker should be movable and tiles should be rotating. And at the end, completion of our drawing notified by a beep sound or a blinking of LED. Then comes our functional tree. There are 4 units in it: holding, drawing, movement, and notification. In holding, a machine should hold a pen or a pencil or a marker and it must hold a tiles. In drawing unit, a machine should draw simple art forms or a geometrical shapes. And in movement, a marker should movable in x-axis and tile should be rotating. And in notification, a machine should give a notification after the completion of our drawing from a beep sound or a blinking of LEDs. And this is our functional clustering.
So moving on, here are the identified subsystems: holding unit, drawing unit, base unit. And we have proposed 4 concepts and selected the concept which is practically possible in essence to the accessible resources. The first concept was a vehicular drawing board which could be radio controlled to draw the desired art form. The second concept was a mechanical X5 plotting drawing board which used stepper motors to control its flow of direction. The third concept was a robotic arm drawing board which used AC motor, DC gear motor, and servo motor to get the desired output. And lastly, the fourth concept uses a tile and linear bars controlled by DC motor and stepper motor respectively to get the desired output. And the puck chart helped select the most efficient and practically possible concept. And now I'll be explaining the virtual implementation of our concept. The drawing board consists of the right side supporting part, the pen holder, left side supporting part, and the base. The right side and the left side supporting part holds the linear bars responsible for the movement of the pen holder with the help of the stepper motor and belt drive, which helps in the horizontal movement of the flow of pen. The base consists of the tile which is rotated with the help of a DC motor and a drive belt, which helps in the circular movement of the flow of the pen. This duo mechanism helps achieve simultaneous linear and circular flow of the pen to get the desired output. For example, if you want to draw a triangle, you will first have to draw a straight line with the help of the linear bars and then rotate the circular tile at an angle of 60 degrees and then draw another line with the help of the linear bar and again rotate the tile at an angle of 60 degrees and then draw a line with the linear bar, and there you have it, a triangle drawn by the drawing board.
Let us look at the circuit diagram for drawing machine. It will be working by connecting a two stepper motor. One is for rotating a tail and another one is for movement of pen holder. And one servo motor, LED, Arduino Mega 2560, connections are made with the breadboard and wires. Let us let us look for the flowchart. This is the flowchart of entire system. When we given the power supply to our system, Arduino turns on. If stepper motors are on, tail start rotating and pen holder start movement. At the meantime, servo motor also turn on and LED will glow if machine start drawing. If not, LED will not glow. Then stop the process when drawing is complete. Let us look for bill of material of this prototype. We are going to use foam sheets for base, left and right body of drawing board. We are using a conveyor belt and bearings to rotating a tile and servo motor and pulleys for rotating a pen, and also using a net, bolts, wire, LED, Arduino Mega 2560 breadboard.
So, motor sizing and battery sizing of the entire system, that is drawing board. Firstly, motor sizing. Number of stepper motor used is 2. Torque produced by each stepper motor is 5.6 kg/cm and number of steps per revolution is 200. Speed of stepper motor is 15 rpm. Number of servo motor used is 1. Speed of servo motor is 60 rpm. Second is battery sizing. Maximum current drawn by stepper motor is 400 milliampere. Number of stepper motor used is 2. Current running time is 3 hours. So maximum current drawn by servo motor is 1200 milliampere. Total current is given by the formula current drawn by each motor into number of motors into running time. So final current is 6000 milliampere hour or 6 ampere hour. So we have to use 5-volt battery for our project, which will run for 3 hours. So function specification of the entire system, that is drawing board. We have listed 6 functions. First is drawing of different art forms, shapes and geometric shapes, which are simple. Second is pen holding, which is custom made, and movement of a tile will rotate in 360 degree, that too in clockwise direction with the help of conveyor belt and stepper motor. And indication after the completion of a drawing, indication is given in the form of blinking of LEDs, which will blink for at least 5 seconds. Size of drawing tile, which is 1 foot, and its rotation and sliding is controlled by servo motor. And movement of pen, that it moves in y-axis, that is horizontal direction. Simulation is done in Tinkercad. In our circuit diagram, we had used 2 stepper motor, 1 servo motor and 1 Arduino. Here, instead of using stepper motor, we had used 4 LEDs, which is equivalent to 1 stepper motor. So in our project, we have used 2 stepper motor. Here we will be using 8 LEDs. And in the code, the pins act as output rather than input. Here you can see 4 LEDs are connected to the pin number 13, 12, 11, 10 and 7, 6, 5, 4, and servo is attached to the 9, and in servo connection, one end it is connected to negative terminal, other end it is connected to the 5-volt, and another wire goes to the 9th pin. So basically in our circuit diagram, stepper motor is fixed at a tile and and servo motor is also fixed near the tile, which helps in angle setting. So stepper motor fixed at a base helps to tile to rotate with the help of conveyor belt and stimulates the and simultaneously marker will be moving so that drawing can be done in easier way.